Good morning, students. In last unit, we have learned authentication requirement, message authentication function, MAC and security. Now we are start with MAC based function. Before you learn a MAC based function, you must aware with MAC address. Is a media access control address. It's called as a MAC address. It is a unique identifier and used to assign in network interface controller. Network address is used for network segment. It is used IEEE 802 networking technologies and mainly used in a medium access control and data link layer. Is typically represent MAC address are recognizable as a 6 group of 2 hexadecimal digit separated by hyphens, colons or without separator. MAC addresses are primarily assigned by device manufacturers and therefore is often referred to as the burn-in address or as an Ethernet hardware address and physical address. Each address can be stored in hardware such as the card, read-only memory, firmware mechanism. This is just only examples. I also give one example. It is Institute of Electrical and Electronics Engineer MAC 48. It used to replace obsolete. Now we are start with another one, the hash function and their application, then security of hash function and the requirements. Now we are also revised the previous topics. Before learn MAC based function, hash function and security of hash function. We are also seeing the secure hash algorithm. I repeat the authentication requirements. This is revision. Is all about disclosure, traffic analysis, masquerade, content modification, sequence modification, timing modification, source repudiation and destination repudiation. Message authentication function is concerned with protecting the integrity, validating identity, three alternative function, message encryption, MAC and hash function used for authentication function. Is use encryption is provide a message of measure of authentication, is a symmetric encryption already revised. The receiver know the sender must have created it, since only sender receiver know key use. Content cannot be altered. Is provide both sender authentication and message authenticity. Now message encryption is a public key encryptions. This is figure how we transfer data from source to destination by using encryption, symmetric cryptographic techniques, and how to use a key and send a secure message to destination. MAC, it is also revision. MAC is a fixed size block of data, is append a message as a signature. We are already learning detail the digital signatures and comparison of MAC. Message authentication code, we are use M here to input a message, C is equal to MAC function, K is a shared secret key and MAC is a message authentication code. Here we seen the MAC is equal to C under bracket K M. MAC, all about MAC, how the entire process is completed by using a MAC algorithm and transmit data from source to destination, and how we secure a message by using a MAC algorithm. Message authentication problem. is concerned with protecting the integrity, validating identity, and how to detect change by adversary to message. Is a solution, is a sign and seal, is more technique, break a message in various part, and authenticator part like a tag. How to do this digitally? Create a tag TM and send tag securely. Message authentication code, still continue revision. MAC provide authentication, message can be encrypted for secrecy, is a separate key for each. MAC either before or after encryption is compute. It generally regarded as better than before. Then why use a MAC? Sometime only authentication is needed, sometime need authentication to persist longer than the encryption. MAC encryption process, here you see the message authentication and confidentiality. The receiver assures that the message is from a light sender because no one else knows the secret key and no one else could prepare a message with a proper MAC. Properties are, is a cryptographic checksum. The requirement for MAC, you need to satisfy the following: is know the message and MAC is infeasible, find another message with some MAC. MAC should be uniformly distributed and should be depends equally on all bits of the message. Now hash function. Hash function is like a MAC. Condenses arbitrary message to fixed size. H is equal to capital H under bracket M. M is a arbitrary length message. Hash function are extremely useful and appear in almost all information security applications. Hash function is a mathematical function that converts a numerical input value into another compressed numerical value. The input to the hash function is of arbitrary length, but output is always of fixed length. Usually assume that the hash function is a public and not keyed, not that a MAC is used as secret keys. Hash used to detect changes to message, can use in various way with message, is most often to create a digital signature. Here I repeat, hash functions are useful and appear in almost all information security applications. Hash function is a mathematical function that convert a numerical input value into another compressed numerical value. The input to the hash function is of arbitrary length. Here we see input to the hash function is of arbitrary length, but output is always of fixed length. यहाँ पे आउटपुट जो भी हमें मिल रहा है वो फिक्स लेंथ में होगा. Value returned by a hash function are called message digest. The definition of message digest is oftenly you seen in GTU papers. So most important for you in terms of marks and knowledge. Here we see the definition of message digest. In another call, we are simply tagged as a hash value. The features of hash functions. A typical features of hash functions are fixed length output. It's called as hash value. Is convert data of arbitrary length to fixed length. This process is often referred to as hashing the data. In general, The hash is much smaller than the input data. Hence, hash functions are sometimes called compression functions. Since a hash is smaller representation of a larger data, it is also referred to as a digest. Hash function n-bit output is referred to as n-bit hash function. This is a small definitions. Popular hash function generate value between 160 and 512 bits. Here we also discuss the efficiency of operation. Generally, for any hash function, h used for hash function with input x is a value for input, and the computation of h under bracket x is a fast operation. This is efficiency of hash function. The another efficiency is computationally. Hash functions are much faster than a symmetric encryption. You remember this thing? Computationally, hash functions are much faster than symmetric encryption. Here we see properties of hash functions. In order to be an effective cryptographic tool, I repeat, in order to be an effective cryptographic tool, the hash function is desired to possess following properties. First is pre-image resistance. Second, collision resistance. These three are properties. First, we see the pre-image resistance means that it should be computationally hard to resolve a hash function. In other words, if a hash function h produces a hash value z, then it should be difficult process to find any input value x that hashes to z. This property protects against an attacker who only has a hash value and is trying to find the input. The second property is a second pre-image resistance. It means given input and its hash, it should be hard to find a different input with the same hash. This property of hash function protects against an attacker who has an input value and its hash and want to substitute different value as legitimate value in place of original input value. Third property of hash function is collision resistance. This property means it should be hard to find two different inputs of any length that result in the same hash. This property also referred to as collision-free hash function. 1 mark question. Define collision-free hash function. This is efficiency of hash function. It's called as a collision resistance. This is answer. How to write in GTU exam. It should be hard to find two different inputs of any length that result in the same hash. This property is referred as collision-free hash function. This property makes it very difficult for an attacker to find two input value with the same hash. Also, if a hash function is a collision resistant, then it is second pre-image resistance. Now we are discuss the design of hashing algorithm. At the heart of hashing is a mathematical function that operate on two fixed size blocks of data to create a hash code. This hash function forms the part of the hashing algorithm. The size of each data block varies depending on the algorithm. Type the block size are from 128 bits to 512 bits. A demonstration: the data blocks are connected with mathematical hash function and it generates a hash value. Hashing algorithm involves rounds of above hash functions like a block cipher. Each round take an input of a fixed size, typically a combination of the most recent message block and the output of the last round. This process is repeated for as many rounds as are required to hash the entire message. Schematic of hashing algorithm is depicted in the illustrations. Like send a one value, it is converted and followed by hash function. Here hash function use a message block 1. Then from another side, in second round, there are n number of rounds and message blocks are used in this process and we get a hash value. Since the hash value of first message block become an input to the second hash operation, output of which alter the result of the third operation and so on. This effect known as an avalanche effect of hashing. This is important and asked so many times in GTU examination to describe avalanche effect of hashing. I repeat the definition. When we use a hash value of first message block become an input to the second hash, output of which alter the result of the third operation and so on. This effect known as an avalanche effect of hashing. The avalanche effect result in substantial different hash value for two messages that differed by even a single bit of data. Understand the difference between hash function and algorithm correctly. The hash function generates a hash code by operating on two blocks of fixed length binary data. Hashing algorithm is a process for using a hash function, specifying how the message will be broken up, how the results from previous message block are chained together. Now in next session we are learn most popular hash functions. Before that we are completing hash functions. You seen here the same thing, hash function and digital signatures. We are almost compare and learn how the hash code is encrypted, public key encryption here using sender private key, and in B they provide authentication. It also provide a digital signature. This is a hash all about use conventional encryption. Hash using public key encryption, then a digital signatures. Now in next we are seeing the requirement for hash functions.